All right, so an arithmetic sequence is a sequence that increases or decreases by a fixed value. So an example would be 1, 5, 9, 13, continuing. And if you notice, the common difference between each of those, in this case, is 4. Now, that common difference, you're always going to find the formula for that would be a to the n minus a to the n minus 1. So for any values here that I had, 13 minus 9 is 4, 9 minus 5 is 4, 5 minus 1 is 4. So in general, the explicit rule is always going to be a to the n is equal to a to the 1, which is my first term, plus n minus 1 times that d. So a1 is the first term, d is the common difference, between all of the different terms. Now, this is the rule that is the most useful, the explicit rule. The recursive rule is a little bit less helpful because for the recursive rule, remember, you always have to have the previous term. That n minus 1 is the previous term plus that common difference. So in this one, you just have to be mindful that a to the n minus 1 is just the previous term. And that's not as helpful as some of the other ways that we can look at this when we have the recursive term. All right, so I just shrunk that a little bit. So what we're going to go ahead and do is look at how to write a rule for a series or a sequence. So if I go ahead and start at looking at an example, if I have 7, 20, 33, and that continues on forever, step 1 is to find the common difference, d. And that common difference in this case is just going to be 33 minus 20 is 13. 20 minus 7 is also 13. So my common difference here is 13. Now, I want to write this both with the explicit and the recursive rule. Let's start with the recursive. The recursive rule is just a to the n is going to equal to a to the n minus 1 plus 13. That's always going to be the case. The one we're going to use more often is the explicit rule. So the explicit rule has the formula of a to the n is equal to a to the 1, and a to the 1, I come back to my original piece, and a sub 1 in my explicit is just what the first term is, so that leaves me with 7 plus, this stays as n minus 1. That will not ever change, but now I have to multiply that times my common difference, and my common difference, I said it before, was 13. So I multiply that times 13, and I do need to simplify this. So now what that leaves me as a to the n is equal to 7 plus, I distribute the 13 to both pieces, 13n minus 13, or 13n, and I combine the 7 and the 13 to get negative 6. So that is my explicit formula for that particular sequence. Alright, so I wrote the formula for the explicit and the recursive rule at the top. Remember, whenever you see n-1, that will always be recursive, and whenever you have an n in the question, that will always be your explicit rule. So I'm going to go through and look at a couple of different sequences that we had before, 1, 5, 9, and 13. And we talked about that before. The common difference with this, 13 minus 9 is 4, 9 minus 5 is 4, 5 minus 1 is 4. So again, that common difference, in this case, D is equal to 4. So the first way to write this formula is just a to the n is equal to a to the n minus 1 plus 4. That is the recursive formula. The explicit formula that I have for this is a to the n is equal to the first term. The first term in the series is 1, so that leaves this as 1 plus n minus 1, that never changes, times my common difference, but now my common difference is 4. So that formula now becomes 1 plus 4, n minus 4, or the explicit formula is 4n minus 3. And those would be the two ways I could express that series. All right, one thing I do need to include with this last one, let me go ahead and take this bottom box off. When you are writing your final answer, you always have to state what your first term is for the recursive formula. Otherwise, you won't know where to start. And your first term here would be different, which would be a problem. So the recursive formulas always have to have that first term. A1 is equal to 1. Let's go ahead and look at another example. And this example is important because it has a sign difference. So if I have 7, 3, -1, -5. Now notice, first of all, it's getting smaller each time. So that should be our clue that our common difference is going to be negative. But we can also here just look at -5 minus a -1 becomes -5 plus 1. So this actually gives me a common difference of equal to a negative. Whenever your difference is negative, what happens is your values are getting smaller all of the time. So that's what's happening with this one. So to go ahead and write the recursive formula, it's just a to the n is equal to a to the n minus 1 minus 4. And we do have to state that a1 is equal to 7. Now, for the recursive formula is the only one that where you have to have that a1. Now, the explicit is an is equal to the first term, which is 7, plus n minus 1 times my common difference, but this time my common difference is a -4. So my recursive formula ends up being 7. When I distribute that 4 to both of those pieces, just watch your signs, because that becomes -4n plus 4. So for my explicit formula, it's -4n plus 11.